Good evening and welcome to the Facebook video lesson from Lindsley Avenue Church of Christ. We're still continuing our series on why I believe. And remember, that title was chosen because it is why I believe. Therefore, it's kind of tough to argue with me of no, you don't believe because of that, because this is why I believe on a large variety of subjects as we have gone through this study. Last week, we switched gears a bit from looking at philosophy, and then we looked a little bit at the reliability of the Bible, and we moved over toward more of a science discussion. I mean, after all, science in much of the world today, from the perspective of scientists, really don't see much of a need for God, that science has it all figured out and explained. And so last week, we talked about the nature and limits of science and how some sciences do lend themselves more toward being verifiable and able to be replicated by other people, whereas some scientific disciplines, because either they deal with the past that's not easily observable or need to require on predictions from models rather than more rigorous, whatever that word means in this context, equations and observations, have a little bit less certainty about them. Well, this week, we're diving into what will be a couple of weeks of looking at biological evolution, which, of course, is the primary competitor, if you will, to creation in all of its varieties, as we'll talk about again later in the future. So jump in with me and let's talk a little bit about biological evolution. Hang in there. So the real question is biological evolution true or false? Here's a quote from Richard Dawkins. He was just recently in the news in early 2024 about how he lamented the decline of Christianity and the effects that decline in culture had on culture. So he now considered himself a cultural Christian, not an actual practicing Christian. But he had some rather tough things to say about people who do not believe in evolution or people who believe in God. So here's what he said in his book, The Blind Watchmaker. It is absolutely safe to say that if you meet somebody who claims not to believe in evolution, that person is ignorant, stupid, or insane, or wicked, but I'd rather not consider that. He went on to explain, by the way, that what he dislikes particularly about creationists is that they are intolerant. Who's intolerant in this situation, perhaps? So, given that I do not believe in biological evolution, you will have to determine which one describes me, whether I'm ignorant, stupid, insane, or potentially wicked. Hopefully, none of the above. There might be a fifth option. So let's talk a little bit about some of the basis for this idea of evolution and gave rise to Darwin's embrace of his theory of evolution. Carolus Linnaeus, who lived in the 1700s, is considered the father of modern taxonomy for his work in the hierarchical classification of various organisms. If you hear about a taxonomist today, many times that'll be if you have an animal that you want to get preserved or stuffed or mounted. People will take some sort of animal who is already dead to a taxonomist and have it preserved in as realistic a fashion as possible. But that's not the primary work of taxonomy. Linnaeus was firmly within the much broader Christian viewpoint, and so his classification system, even when he put mankind, humanity, in the primate grouping, had nothing to do with evolution, but with recognizing the obvious similarities that we have with other primates, which is true. We look a lot more like a gorilla or a chimpanzee than we do a slug. When you think about taxonomy or classification, biologists classify animals and other organisms by categories such as shown here: a domain based on a fundamental internal organizing process of how things work, kingdom, phylum, class, order, family, genus, and then species. And so you have this lovely little red fox over here. You might see one in your yard. Where we likely would be fairly confident in understanding this is that the fox is a mammal, so that tells what kind of class it's in. It's obviously an animal, that tells what kingdom it's in. It is a vertebrate, so it has it's in Chordata, the vertebrate phylum. It is a carnivore, and it goes all the way down to where it is into its species. Biologists classify these animals in these categories And a superficial, if you're not paying attention, if you gave this to maybe somebody in the second grade as an assignment, they might very well group the whale, the penguin, and the shark together because they are aquatic creatures, and birds, bats, and bees together as flying creatures. And certainly that is one way to try to group animals. After all, these animals swim and these fly, so why not necessarily put them together? But the problem is, and the reason taxonomy does not do that, is that the basic body design of birds, bats, and bees is fundamentally different. Their reproductive systems are fundamentally different, and even their wings are only similar in the sense that they all allow flying. Accordingly, the taxonomists agree, as strange as it might sound to the second grader, that the bat and the whale, strangely enough, and it is kind of strange at first glance, should regroup with the horse and the monkey as mammals, despite the enormous differences in behavior and their adaptive mechanisms and how they move and how they live. Bees are built from a fundamentally different body plan from vertebrates of any kind. Bees do not have backbones. And so they go into a different series of groupings altogether, despite the fact that the bee and the bird and the bat fly. Bees are off on their own separate island, so to speak, certainly different from the mammals. Darwin proposed a naturalistic explanation for this essentialist kind of view of features of groups of animals and groups of life forms in the living world that was so stunning in its logical appeal of explaining why you would put a bat, a whale, and a fox in the mammal category, that it conquered the scientific world even while doubts remained about some important parts of the theory. Darwin theorized, that these discontinuous groups in the living world that you see were descendants of long extinct common ancestors, that you had a great-great-great-grandfather kind of thing, or some common ancestor in the past that's not here anymore, and now what you see are these different groups that at first glance don't seem related, but they are from paternity going into the past, or maternity. The more closely related the two organisms appeared to be, the more recently they shared a common ancestor, according to Darwin. The more different they appeared, the further back, as it were, the common ancestor was to have occurred. So Darwin's view was called descent, ancestry, if you will, descent with modification. And so these common ancestors and modification that he called variation, today we tend to call it mutation. Darwin did not have any real feel for genetics. And so he simply said that it was descent through common ancestors, variations arised, and that led to this expanding tree of life, as it were. It shows branch points on this tree in the graphic where you had common ancestors. And so as you get up toward reptiles, birds, and mammals, you can see that they share, according to Darwin, a common ancestor back on that left side toward the middle, a little bit toward the bottom of the fishes. The last time you had a common ancestor between fishes or anything in his tree above fishes and insects would have been way down toward the middle. Crustaceans and insects and things like that have a completely different branch point, and they don't even have backbones. They're not vertebrates. And so their common ancestor, as different as they are, must be much further into the past. Along these solid lines, anywhere in here, and this is a very simplistic graphic of this, you have to have extinct intermediaries and common ancestors. And that means there's got to be a lot of them over the long past that we are told was the way things developed. So Darwin proposed that ancestors had to have been linked to descendants by long chains of transitional intermediates now extinct. You can't go and find your first cousin, your second cousin, your 10th cousin, and so on, or your father, grandfather, and go all the way back to those common ancestors walking around in the woods or swimming in the ocean somewhere. Darwin proposed that they existed, but they have died out. This theory of descent with modification made sense out of the pattern of relationships in a way that was acceptable to philosophical materialists. What does that mean? That means those who believe that the material world is really all there is from a philosophical standpoint. There is no supernatural. Nature is all there is. And so that's really going to be a key, in that the idea that God had anything to do with how things exist today is really off the table. And so if God is off the table, this theory is what you've been looking for, because it gives you a framework that can be viewed as explaining why the natural world as it is and did not require any sort of creator or God. It explained why these groups seem to be part of the natural framework rather than simply human invention. Does putting the bat, the whale, and us into the mammal group, is that just us putting order where there is no order? Or is there a real reason why they belong together rather than the whale, the fish, and some other sort of swimming creature belong as things that live in the ocean? Well, according to the Darwinist imagination, and I don't want to use that word derogatorily, it simply is his imagination at the time, because those family relationships, which is what they believe they are, do not exist in anything that's verifiable from a fossil standpoint. Certainly, they did not exist when Darwin proposed his theory and when so many people jumped to accept Darwinism or evolution. When you combine this idea of common ancestors with natural selection, it explained the difference between common features that are relevant to classification, similar body plans, things like that, homologies they're called, and those that are not, such as analogies. The former were relics of the common ancestor, and the latter, analogies, evolved independently, Darwin proposed, by natural selection to provide very different creatures with superficially similar body parts that were useful to adaptive strategies such as flight and swimming. Again, think of the honeybee, the bat, and the finch. They all have wings of some sort, but those are adaptations, Darwin proposed, for allowing flight, even though they don't share a common ancestor from which the ability to fly came about from one common ancestor for those groups. In Darwin's words, all the difficulties in classification are explained on the view that the natural system is founded on descent with modification. That's a key phrase he uses a lot. That the characters which naturalists consider as showing true affinity between any two or more species are those which have been inherited from a common parent. And insofar, all true classification is genealogical. It is grandfather, father, child. The community of descent is the hidden bond which naturalists, again, those that are as opposed to supernaturalists, have been unconsciously seeking. It's not some unknown plan of creation. It's not something that God imposed for some reason that perhaps people do not understand. It's a result of natural processes, descent with modification. Darwin ended this chapter by saying that the argument from classification, in his view, his explanation for why these seemingly different groups of animals were actually related from descent from a common ancestor, that argument was so decisive that on that alone, he would adopt the theory, even if it were unsupported by other arguments. So how did Darwin think it worked? He thought it worked by descent, but that there would be variations that would occur when new children, new offspring were born. We now would call that genetic mutations, the combinations of the DNA and the sex cells making new combinations. Sometimes they go together and things are different over time. That these would arise from time to time in a parent or be passed down to an offspring, or more likely passed down to an offspring from a combination of the sex cells in the act of reproduction. If it got passed down, if it was something that would take hold, the argument was that it was because it would benefit reproduction. That sometimes we hear about this idea of the survival of the fittest, and that really is saying that changes that are advantageous in reproduction will be passed on to the organism's descendants. If you had a mutation that gave you an ability that had never been seen on the earth before, but that did not create a better ability to produce offspring, it essentially, from an evolutionary perspective, is worthless. I don't know, suppose you generated through a mutation generated, 4 heads, Well, maybe that meant you could see in all directions. And if that kept you from dying from an animal attack, maybe you might actually be able to pass on that mutation potentially to an offspring. On the other hand, if you had four heads and all of your reproductive partners ran away from you and never reproduced with you because you had four heads, it would not be advantageous to passing on that mutation to descendants. More fit does not mean that a mutation made you stronger, faster, smarter. All it means is that you have better success in reproduction. Fitness has nothing to do with physical advancement, nothing to do necessarily with mental advancement. It's only fit in the circumstance where it allows you or the person, the animal, the creature with the mutation to generate more offspring than some other animal similar, right? Cousin, brother, sister, that does not have the mutation. If you were faster because of a mutation, but it meant that you died because you fell more often, the faster mutation might actually be disadvantageous. So changes happen randomly, and if they give an organism an advantage, generating more offspring, that's what the advantage means. It does not mean stronger, faster, smarter. Then the change, mutation, and variation could be passed down to descendants, because if you had 1,000 children because this advantage made you able to produce more children or survive to produce more children, then perhaps this mutation would then take hold of the population group and then would flow down through time. These organisms, being more able to survive, would eventually replace their parent organisms, really just the organisms that came before them, or the brothers and sisters over in this part of the valley or across the mountain over there that do not have that mutation, because your descendants survive more often, and so that would tend to spread, and the other groups would eventually die off. This has led to natural selection sometimes being used as a tautology, even by evolutionists. A tautology is where you say the same thing in two ways. It really proves nothing. And so survival of the fittest means those that leave the more offspring will be those that are most fit, and the ones that are most fit will be the ones that leave the most offspring. Do you see how that said the same thing? Those that leave the most offspring will be those that are most fit. Those that are most fit will be the ones that leave the most offspring. It's very difficult, and it's interesting if you look at quotations from Darwinists, it's very difficult to avoid falling into that trap, because it's seen as such an obvious thing, but a tautology proves nothing other than you can repeat yourself and turn the sentence around. But there are actual examples that are put forward for natural selection working, such as these. And much of this material comes from a book that's several years old now, but it's Darwin on Trial by Philip E. Johnson. If you don't have a copy of that in your library, then that's a book I highly recommend, because as a lawyer, he looked at evidence for evolution and attempted to go through it in a very systematic way. And again, things have changed since that book was written, but he attacked and demonstrated and laid out evidence as it was when the book was written, where people were not questioning it. And so here we go. First of all, we hear about this a lot. Bacteria naturally develop resistance to antibiotics, and insect pests become resistant to insecticides. Why? If you have an antibiotic that kills 99% of the bacteria that are getting you sick, 1% of them survive. And then if those survive, they will tend to reproduce. You might be able to get, if you got sick again and took the antibiotic again, sure, maybe it kills 95% of the ones, but over time, you get a group of bacteria remaining who seem to be resistant. The antibiotic does not affect them. And so that's why we have so much trouble in certain areas of medicine, where we have bacteria and illnesses that are coming up that are resistant to even some of our last antibiotics. Going and getting an antibiotic when you have a virus contributes to this problem. Just because you're sick, please, please don't run and get antibiotics and demand them for yourself or your children. No one wants to hear a crying child, somebody that's sick. We want a magic thing that we can give them that'll make them feel better, but antibiotics only work on bacteria. And by reckless, and it is reckless, use of antibiotics, we encourage, if you will, the reproductive increase of bacteria that are resistant to it, because they keep getting exposed to it. In the same way, insects get resistant to pesticides. If you go out and you just dumped, let's just say, 1,000 gallons of DDT on your yard, you're probably going to kill most of anything in the yard. But anything that's left over from that application of DDT is going to find no one else living in the yard. And so they may very well start spreading. If you come back the next year, oh, I got bugs again, and you dump more DDT on the yard, eventually you're going to have a strain, if you will, of the pests that may set up summer vacation on top of the DDT barrel because they are fairly immune and resistant to its effects. That is a true statement. This does happen. That's why we hear that in the news. In 1898, a storm in Massachusetts left hundreds of dead and dying birds, and someone brought 136 exhausted sparrows who got exhausted from the storm to scientists who ended up killing the survivors, not trying to heal them, killing them to measure their skeletons. And the scientists found that among the male sparrows, the larger birds had survived more frequently than the smaller birds, even though there was only a slight differential in the size of the birds. Now, the issue there is not that birds are always getting larger, but in this circumstance, there was a differential survival rate, if you will, between slightly larger birds and slightly smaller ones. Maybe the smaller ones got blown around a whole lot more, or blown into poles or something like that. But that would certainly be natural selection. In the big storm, bigger birds survived more. That's what we're talking about with natural selection. Another one he found was that then in the Galapagos Islands, and that was a really famous set of islands off the coast of Ecuador in the eastern Pacific off of South America, where Darwin himself went, a drought in the Galapagos Islands in 1977 created a shortage of small seeds on which finches, these birds, fed. After one generation, there had been so much mortality among the smaller finches who couldn't eat the big seeds, right? The small seeds weren't there, so they didn't have a food source. So the smaller birds died off, and that meant that the average size of the birds, and especially their beaks, went up. Average size. The big birds were already there. Smaller birds died. The bigger birds who could eat the big seeds that were not in a shortage situation were kind of now the more common bird that you would find. Well, Futuyama said, very possibly the birds will evolve back to their previous state. That is, that mix of big birds and small birds might shift back towards smaller birds if the environment goes back to normal. But we can see in this example what would happen if the birds were forced to live in a consistently dry environment. They would evolve a permanent adaptation to whatever kinds of seeds are consistently available. This is natural selection in action. It's not a matter of chance. Well, if your small seeds are gone, and it's going to be really hard for birds with small beaks or smaller birds to eat, and so they will die off. That is not so much any kind of example of evolution in the sense we're discussing here. It's pretty obvious that if you can't eat this huge whopping seed, that you likely are going to have a tough time surviving. In fact, it turns out in an article in 1987, small birds survived much better than larger birds in the wet year of 1982, which revised the trend. So it's probably a good thing there was still a selection of small birds and big birds, even if the percentages went different ways, to avoid all the birds dying off. If this had worked completely the other way, if all small birds had died off, you would have had the huge birds, 1977, and then when the other kind of weather came, all the big birds might have died off and you would have no finches. So yes, there will be pressures that may favor one group or another over time, still have finches, some bigger, some smaller. The allele, or genetic state responsible for sickle cell anemia in African populations, is also associated with a trait that confers resistance to malaria. Individuals who are totally free of this sickle cell allele suffer higher mortality from malaria, and individuals who inherit the sickle cell allele from both parents do tend to die early from anemia. Chances for survival are greatest when the individual inherits the sickle cell allele from one parent but not the other. Think about that. If you don't have sickle cell inherited, the allele, the genetic material, the genes for that from either parent, if you don't have it at all, then malaria is much more likely to really treat you very harshly. And having just come back from an area in Africa that's very, very wide spread with malaria, this is true. You get malaria and don't have any sort of resistance to it, malaria is a bad thing. On the other hand, if you got two copies of the allele that is responsible for sickle cell anemia, your oxygen cannot carry enough, your blood cannot carry enough material to keep you alive, and so you can die from anemia. If you have one copy of it, yes, their sickle cell anemia is bad by having any of it. So you suffer from that, but you get some resistance to malaria. So on the whole, it turns out the presence of malaria tends to select for those who are partially resistant with one copy of it, not for those who have no copies of it or for those that have two. Putuyemia comments that not only does this show that natural selection is effective, but that it is an uncaring mechanical process. You know, the way the natural world works here is not to try to avoid people suffering. It's, in this case, the circumstances that individuals are in will tend to lead to the survival of those who were, strangely as it sounds here, best situated to survive given the environment in which they are. So if malaria is there, this thing that causes sickle cell anemia, especially really severe if you have two copies of it, tends to promote the survival of those that have one. That's the way it works. Finally, he also talks about Kettlewell's famous observations of what was called industrial melanism in the peppered moth. When trees were darkened by industrial smoke, dark-colored moths became abundant because the predators, think of birds seeing a moth on the side of the tree, couldn't see them because they were dark and the tree was dark, and so they didn't see them. However, they became abundant. Light-colored moths did not, because if you got a dark tree and you're a very light-colored moth, the bird zeroes right in on you. So light-colored moths became very rare. They didn't die off completely, but they were easy to spot by the predators. When trees became lighter due to reduced air pollution, the lighter color moths had the advantage. So what his observation showed was how the prevailing color of the moths, the higher percentage color of the moths, the white and dark moths, the light and dark moths were still there. The percentage of those that were dark increased when the trees were dark, and it came back the other way when the trees lit up. However, if all of the light variety of moths had disappeared when the trees were dark, then when the trees became light again, the moths might have just gone extinct. So yes, external things can cause changes in the population percentages, but that's hardly something that's controversial. So what can you think about some of that? Well, there's no reason to doubt that some circumstances can certainly favor drug-resistant bacteria, large birds as opposed to small ones, or dark-colored moths as opposed to light-colored moths. It's possible in this case then that certain bacteria that's not resistant or smaller birds or light-colored moths may become reduced as long as circumstances prevail. But none of these proofs provides any persuasive reason for believing that natural selection can produce a new species, new organs, or other major changes, even minor changes that are permanent. In sickle cell anemia case, for example, it merely shows that in special circumstances, an apparently disadvantageous trait may not be eliminated from the population. It also would show potentially that larger birds have an advantage over smaller birds in high winds or droughts, but it doesn't have any tendency to prove whether similar factors caused birds to come into existence in the first place. Very likely, smaller birds have the advantage in other situations, which explains why birds are not always big birds. That's why we don't have 50-foot birds, and there hasn't been pressure to make birds bigger forever. So descent with modification does imply an enormous number of extinct intermediate species throughout past history. Darwin posed the question like this: why, if species have descended from other species by insensibly fine gradual changes, do we not see everywhere innumerable transitional forms? Why is not all nature in confusion instead of this species being an identifiable group and different from this one and this one and this one? Why do we see them well-defined instead of confusion in biology and in nature? He answered with the theory of extinction, that these intermediate forms had died off because they had not been able to survive, meaning not generated as much offspring, as many offspring, as had the one with the advantage of being able to produce more offspring. The appearance of an improved form was an implication of a disadvantage to its parent form. This examination by obsolescence, or extermination rather by obsolescence, this extermination by extinction implies that appearances will be against the theory of evolution in our living world, because we see distinct stable species and larger groupings with only rare forms that appear to potentially be intermediates. The links between these groups that once existed have vanished in the past due to not being adapted well enough to maintain their reproduction in numbers to keep them alive. They have gone extinct. But what if the necessary links are missing not only from the world of the present, but from the fossil record of the past? Darwin acknowledged himself that his theory implied that the number of intermediate and transitional links between all living and extinct species must have been inconceivably great. He never postulated that you had a snake egg out of which came a bird with a huge jump. It had to have been slow gradual changes so that you could line up huge numbers of potentially more advantageous forms and really not necessarily notice any external changes. If that were true, then you would have huge numbers of intermediate forms and should be able to line them up around the block slowly over time as you line them up, seeing differences between them. One might suppose that geologists then are always uncovering new fossil evidence of transitional forms, but that was not the case back then. What geologists did discover was that species and groups of species appear suddenly, and suddenly means a different thing to scientists working in paleology and fossils than it would to you and me. But even from their perspective, they considered it sudden rather than at the end of a long link of chain of evolutionary links. Darwin conceded that the fossil evidence as it existed in the mid-1800s was the most obvious and gravest objection which can be urged against my theory. Stephen Jay Gould, now sometimes if you use these quotes, you'll get accused of taking them out of context, but it's hard to know what they mean if they don't mean what they say. So keep that in mind, that if you were to use this and talk about this with someone who is a naturalist, they will tend to write it off. But when you have a paleontologist who makes these kinds of statements in a moment of candor, here's what he said. He said, Stephen Jay Gould described the extreme rarity of transitional forms in the fossil record as the trade secret of paleontology, fossil hunting. At the very least, he's saying that we don't have huge numbers of intermediates that we can line up in fossils one to the other in a long chain to show exactly how things happened. They have things they might think came here, but still, it's not some sort of glorious revelation of the past that would be needed to show the kind of record Darwin had proposed. Stephen Stanley explained that the doubts paleontologists had had about gradualistic, slow, gentle evolution from one slight change to another were for long years suppressed. Now, why would that need to be suppressed? Think about that for a minute. Remember, people we're talking about here, by and large, are naturalists, and God is off the table as an explanation. And so if God is off the table, this is the only option there is. And the last thing they want to do is to give ammunition or arguments to those who want to bring God in the front door. He wrote that the process began with T.H. Huxley back in the time of Darwin, who muted his negative attitudes toward gradual change and natural selection because as a believer, he was not inclined to help those who were disposed to throw the baby of evolution out with the bathwater. Well, if the lack of fossils might cause people to throw out evolution because you don't have the fossils, then maybe it's hard to separate the two. Niles Eldredge said that we paleontologists have said that the history of life supports the gradual story of adaptive change, all the while really knowing that it does not. That's a hard one. This led to the development of a new version, if you will, of evolution called punctuated equilibrium, where more larger changes happen in isolates over here, separated from the larger group of the organisms that did not experience the change. And therefore, because it was a small group over here, you would not expect to see the fossilization of that. One of the concerns for that is, really, throughout all of life's history as it's presented by Darwinists, all the changes happen to occur over there somewhere, and we're just never really going to see much of any of them. I do tend to think that's an unfortunate convenience if that's what's being talked about. So again, why are atheistic scientists so committed to Darwinism? Well, why are small changes accepted as the way large changes can come about with such odd evidence? Why is natural selection, which may make a difference between how many light-colored moths and dark-colored moths there are, why is natural selection that might make a difference between bacteria that are resistant to this becoming more prevalent? Why is natural selection that says that the roaches that can drink DDT and still survive happen to be the roaches that now live everywhere? Why is that kind of evidence that gives support to the idea that an eye or a bat's wing can come about through the same process? Well, the National Academy of Sciences told the Supreme Court in one of the cases dealing with equal time for a creationistic viewpoint and evolutionary viewpoint, said that one of the basic characteristics, the most basic characteristic of science is reliance upon naturalistic explanations as opposed to supernatural means. It is true, we wouldn't get very far if every time you flipped a switch on the wall, you assumed that there was a miracle that caused light to show up. We know from a scientific viewpoint, I mean, if you've done wiring, that activates things and it turns on a light when you flip the switch. The reliance upon naturalistic explanations is the way a lot of stuff gets done. However, we understand how the light switch turns on the light bulb. We can see it, we can duplicate it. What we're talking about here are things that are making sweeping observations and making sweeping suggestions about the natural world that, remember, the nature and limits of science are just not visible to our eyes and can't be put in the laboratory. Contemporary scientists place God, but any non-material vital force that would drive evolution to generate people or anything else, God is off the table. God is off the table. So if science is to have any explanation for biological complexity, it has to make do with what's left if you throw God out the window. Natural selection then is the best of the remaining alternatives and maybe the only alternative, and so it must be possible. It's all there is. It is the only game in town. That's why scientists that do not believe in God have to, they believe that this is in fact the only real explanation. If it's your only allowable explanation, it will be the explanation. I want to thank everyone for joining us. We will get back on this next week.